I want to talk about towers and lattice towers and stuff for a second. I've used them. I actually had a lattice tower once and they're brilliant, and don't get me wrong, but it's people who watch me build this thing and they often say, oh, just buy a lattice tower and be done with it. Now in the UK, a lattice tower is normally sectional and nested, you know, with steel ropes and everything. Just bear that in mind. But why did I build this really? So, I mean, apart from the ropes, shackles, turnbuckles, stub masts, consumables, right? In many ways, you know, in terms of cost, I suppose, the system around the tower is kind of identical, really. Mine tilts over and a lattice mast very often nests with wires. In the UK, most of these towers come in, I think they're 6 metre or 20-foot sections. They're not exactly chuck it in the car, you know. I can get all this on my roof rack. And remember, this is a sheep field, okay? They're all out there right now. One day this might want to be a sheep field again. If I've got 2 tons of concrete at the base here, how are they going to get that out? And then we got maintenance, all right? Steel ropes, bearings, pulleys. It all wears, all right? And let's be honest, most second-hand towers you see are second-hand for a reason. When a lattice tower fails, it tends to fail in quite a big way. So let's compare that to this mast, which, as you can tell, is currently down. Well, I can operate this on my own completely. I don't need a team. I don't need a plan, you know. I mean, I need a checklist. The only thing I really need to do, this is the falling derrick here, is remember to put the falling derrick lines on and press a button. And as you saw in yesterday's little live stream, it went from fully upright to on the ground in minutes, right? It's kind of simple. There's no cables really. I mean, there's just the falling derrick, right? And then strength. I mean, at the moment we're on 8mm poly rope. Once we swap this to Dyneema, we're talking of possibly the capability of this, we've worked out, is over 1,000 kilos downward force. The whole thing only weighs 70 kilos. And it's just scaffolding, right? If something bends or breaks, which it did last week, I mean, you know, we were testing, it was my fault, all right? I mean, the whole thing was scrapped, but within a couple of hours, we had it all fixed. Now, I'm not ordering or trying to find a section for a 100-foot lattice tower or something, you know. And then finally, this is incredibly flexible. It's good fun. It's a piece of, it's part of my hobby. You know, to be able to create and build something like this is just such good fun. It just, yeah, I can't believe we got it up and working, to be honest. So that's the why. I don't want a lattice tower. They frighten the living daylights out of me. I always need a friend to help. You can't even lift a section on your own. Now, I had a couple of questions going, I can kind of work it out, sort of, but how did you actually build this? How does it work? So, we have a hinge in the middle. From that hinge, everything else is super accurate. So you got a laser leveler, and every single guy point is exactly the same height relative to gravity as that hinge point, which means when these ropes stretch over, nothing goes under tension because everything is identical. And there's a bit of magic as well. It's that if you do make everything identical, when it's lying on the ground, there's a tendency to wonder, well, how long should the back guy be? Well, it's very simple. We make a dummy line from here to one of the side guy points, and it will be exactly the same size, because everything is the same. So when it goes up, it just works. Now, I've put my rotator at the base here. Optionally, you can put it up high. I don't like all that weight up there. I've done it this way. There's no pressure on this when it's down, by the way. You could lift that up. That weight's probably 20 or 30 kilos. It's just sitting down here. It's fine. Don't worry about it. I happen to have an insulator here because we want to turn this into a vertical one day. And this is a piece of that's a scaffolding connector. It's a hinge. It just comes over to allow me to drop the falling derrick over. That's supposed to be slightly loose, by the way. Don't worry about that. Now, mine is a dual use tower. I wanted a 4 square and a tower. and I have limited space here. Now the books tell us don't put a mast inside a 4 square, but I did the calculations, and as long as we detune that mast, and it is identically, it's symmetrically right in the middle of the 4 square, it should be invisible, and as been proved, it is. So being a 4 square, we need very precise, accurate measurements. Out to each of these guide points is 7.38 meters, I think, to each guide point. So I cut a scaffolding pole, put it in with a lump of concrete, you know, and they've been in now for, I don't know, a couple of years. And it's the guide points that are my restriction. I can't go out any further or any less. I really wanted a 4 square and a tower. And originally it was only going to be a 2-section tower. But, you know, we have ambition, don't we? Can we make it a 3-section? Well, I've done it. So geometry, you can now see how it all works. When that falling derrick pulls up and is tucked away and I can disconnect it, you just have 4 guys per section holding the thing up. I used to hang the falling derrick over here, but I don't. I just leave it on now. Right? So there's not part of the antenna system or part of the mast when it's up. It's only to assist the thing going down. Before I cover the cost, I just want to say that a scaffold pole with a 5-meter guide point is, I believe, like a Coke can. The crush potential is something like 1,100 kilograms. At 6 meters, it's about 1,000, and at 7 meters, it's about 800-900. That spec is well known, well understood. Because of that, the first 2 guide points, because they're steel poles, can be locked off and pretty solid. If you like, the top aluminium pole is supposed to be, this is a retrofit, it's supposed to be a little bit more flexible. I'm not supposed to put as much tension on this top pole. That's aluminium where the Yagis are. So if you like, treat the first 2 steel poles as the base of my antenna world, right? Once we've got the dyneem on, it should be locked off absolutely solid. And even in a storm, you might see it move that much. Right, now the cost. I've worked out the whole cost of this, which I've dripped out over a period of a couple of years, is about £850. That's the winch, the box, the car battery, you know, these lifting eyes, 16mm lifting eyes, bits of scaffolding and all sorts. Everybody needs a rotator, so I'm not factoring that in. All right, but the scaffolding poles, about £120. We've got these Yaesu thrust bearings. They're about £60 each, £70 each. These, we got 3 of these. Then I bought the upgrade. They're quite expensive, maybe £30. The upgraded pole joiners. So £850, super flexible. I can dismantle it, put it on my roof rack. I could put it somewhere else. Right? I'd need John with his JCB to pull it out. Hopefully, if I've not explained properly, please ask. But since you all loved the end of the last video, I will drop that in again. The majesty of this thing going up at the press of a button is absolutely wonderful. Hopefully that has inspired you. And by the way, if I had a smaller lot, I'd do this with 2 steel scaffold poles, a falling derrick, a couple of anchor points, and you could have a 12-meter, 40-foot tower mast, easy, for probably £250. All right, let's fire it up. See you next time. Bye for now.